How many people here have folks in their office using continuous integration tools? Jenkins, Travis, things like that. People actually, do most, the rest of you guys know what it is? Well, we'll get to that eventually. So I actually work for, I'm Matthew Barr. I actually work for a company called Snap Interactive. We run a dating site called AYI and blah, 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 blah. Okay. So I've been a team lead for the operations group here. I've been a sysadmin for about 15 years. DevOps, WebOps, all those nice things. LAPSA and USENIX member. You can find me on Twitter and on GitHub at Matthew Barr. And this will be in the end stuff too. But that's where a lot of this code is published. So, continuous integration. The practice of frequently iterating one's new or changed code with the existing code repository. Yay. You're going to go, it basically means you're maintaining a code repository, which if you're using a configuration management tool, you should be using a code repository. I don't actually care which one you use, although one that's server-based not like would be better, or something that's distributed. Something newer than CVS would probably be all that I really care about here. And if you're still using RCS, well, I hope it works for you. I hope. It allows, continuous integration allows you to automate the builds, make builds self-testing, keeping the build fast is an ideal, and everyone can then see the result of the builds. This came from Wikipedia, I believe. Just go ahead and get a definition up. So, background on some of the basic tools. Folks have probably heard of Puppet. It's been mentioned a few times. It's Puppet Labs. It's a configuration management tool with a DSL. It's fairly similar to Chef in that it is the same general type of system. It doesn't use SSH as its protocol. It does its own thing. It's an agent, etc. Jenkins. It's an extendable open source continuous integration server. It's at jenkins-ci.org, and it looks a lot like that, which you can't really see, can you? That's in theory a red or a green ball. So let's do this. We're going to go ahead and go over quite a few things in this, so I'm sorry there's a lot. Not going to go super far in depth in any of the areas, but hopefully it's enough to keep you guys interested. And hopefully it's things that will actually apply to what you actually do in your offices or design for your environments. So covered setup, which is things like dynamic environments and Jenkins. Static analysis tools, which in the case of Puppet is Puppet parsing, ERBs, and things like that, and linting. It could be something else if you're using Chef. They do have tools that are analogous, as well as CF Engine. They do all their same stuff. So then module testing. Catalog testing, which is something specific to Puppet in this case, but it's just the process of compiling the catalogs for the end nodes. Dynamic analysis, which is really testing deployment and also running integration tests, and then nightly rebuilds. Now, after that, you get to actual deployment, and you end up with testing things on Canary servers, and then rolling out things to production. Well, that's great, but we're going to go ahead and stop here for a second. And this is about CI, but CI begins at, well, work. If folks haven't heard of Vagrant, who's heard of Vagrant? Who uses Vagrant for their development work? Or, and when I say development, I mean systems administration, really. So the tagline for Vagrant is create and configure lightweight, reproducible, and portable development environments. Well, it's great they say that it's a development environment, but it really works nicely when it comes time to try and test things that require multiple systems to test and work on. So I figured I'd go ahead and give you guys what I actually have as my Vagrant file. Basically, you've got a definition of a box, and then you've got two different systems, one of which is my Puppet master, and the other is my node. Vagrant allows, if you're using, you could actually switch probably 2 words in this, and it would probably be a chef. Another couple, I suspect, you could pop in CF Engine or something along those lines, or bconfig. So really, this just goes ahead and builds out a machine that is actually a master, sets it up, puts into place all the shared folders so that you can then serve as a master, I actually end up doing a little more than that, in that I put in an entire copy of EPEL, CentOS, and some other things onto the test node, onto the Puppet master node, which lets me then go ahead and have a clean node as my client, and then run a full config and see how well it works from a clean build. It's not quite the same as a full clean build from a kickstart, but it's pretty close, and was enough to go ahead and let me do a lot of the work that I needed to do on a trip out on the plane, and actually see how well it was working, and make some pretty heavy changes to code without having to go ahead and commit and go out to a server and then deploy and all the other processes. So this is pretty much just a graphical, quick version of that. The host system talks to the Puppet master, which then can talk to the client. I can actually SSH to all the machines, but that's pretty much it. Another thing, if people aren't using pre-commit hooks and you're working with configuration management systems, you probably should be. You need to make sure that your code is clean before you're committing, ideally, as opposed to afterwards, which is where most of the talk is focused. It'll make your life much faster if you find that you've missed a colon or a semicolon or a bracket or something like that before you put that code in, and then have to go ahead and make yet another commit so that everyone sees how silly you were. So I'm going to go over, this is really fairly specific, but Puppet allows for something called dynamic environments, which uses the Puppet environments function. If you just go ahead and Google Puppet dynamic environments, you'll find Adrian Thiebaud's blog post at Puppet Labs. This is based off of, that example is based off of Git, but the end result is that each branch in Git ends up as an environment that can be specified from the command line, and you can test a branch without it actually going out to all the machines in the system. So it's really helpful, and it can be used as a hook or a web call from GitHub or something like that. Jenkins. So we actually go ahead and have code that actually manages the install of Jenkins. We actually use the rtyler Jenkins module, which is there. It allows for base installs of Jenkins as well as slave installs, and dynamically adds slaves to the Jenkins instance, which is really great if you're using it for code deployments and things along those lines as well, or for testing a lot of large sets of tests and things. It also does plugins, which is kind of helpful for this because the code actually requires about 10 sets of plugins if you include things like RVM and such to really go ahead and make sure that all your things you're testing are working. And this is what Jenkins looks like. I don't know that everyone can see it, but this is basically a multi-job, which ends up giving you the Puppet CI job and then has sub-children. And it allows you to group them, run them in parallel, and give some idea of actually the status of how far everything went and each individual build. Now, we use GitHub. So we have pull requests. Pull requests have, I think, been implemented into various other systems that layer on top of other source control systems. I think Bitbucket has them from Atlassian, which allows for Mercurial and Git. I'm not really sure what else has them. I know there is a GitHub that's actually enterprise-based as well. I'm guessing you could probably go ahead and replicate the functionality with Gitosis or Gitolite or something along those lines. It allows for some code review, some commenting, things like that. But in this case, it's a point in time where you're saying, I want to test, this is the code I want to merge into my prod code base. It allows the system to go ahead and say, this is what I'm going to test, and then come back with a status on it. That's actually just allows you a point in time to really do that. We actually use a module for Jenkins, which is called the GitHub Pull Request Builder, which listens for a pull request and says, OK, I'm going to go ahead and trigger a Jenkins build, and then updates the status. And it looks like this, actually. So you can actually see up here that it has a status of good to merge, which means that it's actually completed the check. You can't really see it over there on the far end of the commit, but where that other arrow is pointing is actually a check mark, which actually links to, it checked that commit against the entire Jenkins build process and has come back and said this has passed, and that's what actually has updated the good to merge area. If it had multiple commits, one of them failed, you've come back around, fixed the problem, put another commit in, it automatically added the pull request, and then it tested, and then now it would come back as clear and good to go. So that's pretty much the setup that's needed. Then there is basically the start of the meat. Static analysis. This is the stuff that most of us probably are doing on your configuration management code as it is. In this case for Puppet, it's the parser syntax checks, which I have there. There's ERBs for the Puppet templates. There's Puppet linting, which basically does making sure that you're following the style guide from Puppet. Turn certain things off if you really don't feel like checking all of them. Things like 80 character lines are sometimes an interesting one that I don't particularly like. And allows for checking YAML as well, although I'm still looking for a good tool for checking Hira YAML files, just because YAML is not actually quite the same spec as Hira, it's just a subset. So how does this actually work? So it catches errors in syntax and styling. So it turns out that on that line that says ensure, there should be a comma. It's going to break. And if you were to run it, you'd actually see that. So there you have it. It's saying it needs a comma. It doesn't say it needs a comma, but it actually does. I think that's actually finished in the new parser, to be honest, in 3.2, but that's OK. And then Puppet lint basically goes in and says, well, you haven't filed the style guide. You've got tab characters in there instead of 2 spaces, and you're not using indent. You're not actually matching up the indents of the assignment operators and things like that. So that's pretty much what that gives you. Okay. From there, you can move on to module testing, which uses typically in Puppet. You use rspec-puppet. It works well for testing an advanced testing of a single module. It doesn't work as well for complex, the entire environment, but it does allow for testing complex internal logic inside of a module. For example, I'm sorry you can't see that all that well. The part you really can't read is a comment, so don't worry about it. This is actually just the rspec file from Puppet Jenkins, and basically goes ahead and says that if you're on one Red Hat family, then you should have X, Y, and Z. And if you're on Debian, you should do A, B, and C. I tried to keep it fairly easy. You can see it's just rspec, but it does work fairly nicely and allows you to look what's inside the catalog and say, OK, this is what it should have, and do some fairly basic stuff. It isn't actually designed to test the actual execs or things like that necessarily. If you're doing that level, you probably shouldn't be using rspec for it, but you should be using this to go ahead and make sure that the logic inside the file is actually, the module is actually being properly followed. And so you can go ahead and pass it and set up initial guesses and assignments to go ahead and see what happens if you were to run this on another type of system. From there, we go on to catalog testing. So basically, catalog testing catalogs are the unit of moving the list of operations that have to happen from the Puppet master down to the actual node. The process really happens is that the node starts talking to the Puppet master, sends over a list of facts, and then the master builds out a catalog, then sends the catalog back to the node executes it. So it turns out you can actually cheat and test the catalog to make sure everything will process syntactically and compile without actually going ahead and doing this on the node. One of the ways you can do it is by basically telling it that you can do You can take the actual system and cheat because it stores the facts on the master. So if you've got a machine like your prod web server, you can actually come back, have it compile a catalog for the prod web server with that new branch of code that you're bringing in and see if it actually would work. Another option for this is actually Levy's manitest, which I linked. So this is pretty much what it looks like. This is just a quick test script. But if you had a problem and you were using a template, for example, and you listed that it had to look, a specific host should use a specific template file, version of the template or some such, and the template, that file didn't actually exist in the actual code base. This is where you would catch that kind of a problem. So if you specified that there had to be a file that had, for example, this test right here, where you're compiling web01.example.com, you would actually see, if you'd specified that in Puppet, and I'm sorry I don't have a slide for this, I apologize. If you had a Puppet command that looked for the source of a template file that listed, path/hostname, FQDN. Well, the code looks correct to Puppet. The parsers would all go ahead and go through without a problem. But this is where the actual system would say it doesn't exist because you didn't ever create the actual file. And this would actually help you find and catch a problem before you went ahead and were supposed to deploy it to, say, someplace else like prod. This could really use a slide, obviously. So, oh, you know what? Never mind. I'm wrong. I do have slides. So, catches dependency loops, unknown modules, variables, and facts, which looks a lot like that. If you specify a class that should be there and it isn't there on that version of the code base, this will catch it. If you specify a template which isn't there, you'll catch it. So moving on, dynamic analysis. Well, so you can actually test deployments. You really want to test deployments to all your critical systems before you go ahead and approve your actual code base and go live with it. So you can go ahead and see the changes on each type of system, maybe go ahead and gather them up. And this is going to catch problems where you've specified a version of a file, an RPM, or you've defined an RPM, a YUM server that doesn't exist, for example. And it'll also help catch config files that actually don't work. If you were, for example, to deploy an Apache config file that has errors in it, nothing in your configuration management system is going to go ahead and stop you from deploying a vhost file that doesn't close and onto all your prod web servers because you've just added something new, and it would just not work if you restarted Apache. Well, you'd be really up the creek at about that point. So this will allow you to catch those errors, though, before you actually get it into prod. So that can look like something like this. And in that case, what you're really doing is going out to your test servers. You're applying an environment and bringing it into Jenkins. So you can see on the bottom, I don't know, how readable is that? That one's actually pretty readable, isn't it? Can you guys read it in the back? No, sorry. Size, not so helpful on content. Basically, what you're seeing is the actual output of a Puppet run, a Puppet agent-t run. And I actually ended up having to write a parser for Jenkins to go ahead and look at the actual content and determine what is a good output and what isn't a bad output. And I'll show you the output in a sec, the parser. It's actually a very short parser. But basically what you're seeing here is because something wasn't available, you've got an error. You can actually see down here there's an error downloading a package. Because that package wasn't available, the system's actually going to fail. The Puppet run would fail, and that actually should be listed as a break in your build. Now, this is just the quick parser, just in case for those who want it later. Don't worry about it. Basically looking for errors and noting when they're finished. Integration testing. So integration testing covers critical functionality. Okay? This is really where you're going to go ahead and, after you've deployed to a test server, how do you make sure that your system is actually still good? It could be as simple as just doing a curl. It probably isn't, though, as simple as that. But if you've got a basic web app, and all you really need to make sure of is that Apache is still running, and that the code is that because the app has the actual real prod code or something similar to it deployed, and the app actually connects back to your MySQL servers and everything else, well, a curl would actually do a pretty good job of telling you that the actual system is up and running and that you haven't broken your Apache or your MySQL or anything else. So it isn't so bad of an actual thing, though. Now, what I'm doing here is really basic and easy. You could do a lot more than that in your integration testing. Something that some people use would be some of the Nagios checks, for example. If you do a Nagios check here, if you run the Nagios modules, it will actually work perfectly. It'll fairly well simulates the same problem set, and you're using those checks already for your monitoring. So they're probably pretty robust at this point. Excuse me. Now, that's all great until you get to the point where things happen. I don't know if you've ever tried to go ahead and not built new systems for a couple of months or whatever it may be, or haven't built that type of machine lately, or just turned around one day and had your managed care facility go ahead and change the satellite builds that you have, and you suddenly notice that you're getting new versions of packages because 6.4 came out and they decided to move everything over to latest on you. Don't do that. I wouldn't recommend it. I actually caught that last year when I started my job. The systems were actually running late against latest, and 6.4 came out that day, and a machine that I had built 2 days before worked perfectly. A machine that was given to us that day did not work so well. So how can you go ahead and cover yourself against this kind of a problem, or repos changing, or other servers being down, things along those lines? You can go ahead and rebuild them from scratch frequently. So this will let you go ahead and ensure that you can actually build your DC from scratch if you had to. If you can't build a machine, having it in configuration management isn't going to help if you can't provision new systems. So, yes, and only you can prevent bit rot. So how do we actually do this? We actually have a script. This is actually Fog, mostly using the Fog library from Ruby, that goes ahead and goes out, connects to our vSphere server, and actually goes ahead and builds and clones a system, which is merely an actual base template image. It doesn't have a disk in it. It actually will just come up with some settings in terms of RAM and CPUs. Comes up and then grabs the MAC address, adds it to Cobbler, which we're still using because it was fast and easy. And then Cobbler goes ahead and adds it to IPA, which is an integrated LDAP, DNS Kerberos solution that's the upstream of Red Hat Identity Manager. And then it goes ahead and goes back to the vSphere and turns the machine on, which then provides, promptly kickstarts and comes up and etc. And now, if you go ahead and build things from scripts, you need to know how to clean them up. And this is pretty much just a script that goes out, goes on to the vSphere box, shuts down the VM, destroys it, gets rid of it, and then comes back in and goes ahead and gets rid of it from Cobbler, removes the Cobbler profile, removes it from IPA, removes it from Puppet, and allows you to go ahead and do this as often as you'd like. So if you go ahead and clean up after yourself, you can keep doing this as long as you need to make sure all the systems are working. Or if you're just doing dev systems, you can go ahead and iterate on them fairly quickly. And I'm going way faster than I was expecting. Anybody have any questions, by the way? Microphone.
Could you just repeat this? There was an environment file. What's the contents of that look like?
So the Puppet environments file? Hold on one second, I'll tell you. I'm pretty sure you've got a question. I'll answer it quickly, or not. OK. I'll answer Tom's question. I actually still have some stuff to finish, but the Puppet environments is actually not a file. That's the best part about it. It's actually stored in the puppet.conf on the master. And that defines that if you go ahead and look for a specific branch name or directory, you can actually specify wildcards of an environment in the actual path to the modules. And that will allow you, based on the environment variable that is sent, hold on a second, let me go back. Right there. See where I say environment? And I have a pull reconv, is what that is. That's just an environment name that's passed back to the master as saying, this is my environment. And because that's actually available, you can actually use that name, that variable, inside the actual, while determining which module path to give you back code from. So basically, I can have my prod environment, I can have testing, I can have all the different code branches. And so we're actually using, in this case, pull reconv, because I need to have a static one for some other reasons. But if I was doing manual testing, though, I could actually say feature name there, and then test on like one server that's being brought up, and just test that one. Now, the real answer to this is, go look at the thing I Googled, the dynamic environments. Just Google dynamic Puppet environments, and it'll describe this whole thing. So that's a blog post by Adrian Thiebaud, who came up with the idea in the first place before he was at Puppet, and then wrote it when he was at Puppet, though. OK. Second question.
Have you looked into using the Sonar source metrics system for static analysis and dynamic coverage analysis?
I haven't. Not familiar with it off the top of my head.
OK. And then one of the problems with automated tests is that tests are software that will have errors. How do you build confidence in your CD pipeline?
OK. So how do we go ahead and build confidence in what we use? So the tests are sometimes broken. The trick is to go ahead and find ways to go ahead and get around that by using things and tools that are either likely to break in the same way every time, or so integrated into the actual tool that you're using that if it breaks, then you're probably doing pretty well. Now, I will say that, for example, I've actually seen a problem on this where if the parser is not actually, the file for the parser isn't there, it will actually break the test and fail. And so you pretty much just have to go ahead and know and automate your build systems to go ahead and make sure that you're doing it right. The trick is, if you're using Puppet to go ahead and establish and build your Jenkins system, then it's less likely to break in an unpredictable way, because that's the whole point of using configuration management, to go ahead and make it repeatable. So going on from nightly rebuilds, there's also canaries. I don't know if, is everyone familiar with canary in the coal mine, the expression as the idea of making sure, there was coal miners used to have canaries in a little basket, and if the canary died, then there was probably methane, and they needed to get out of there because they were about to go ahead and die. So the canaries had a lower tolerance, though, than humans, and so there was still enough time for the humans to get out of there because the ventilation systems had broken, or there was bad air, or whatever it may have been. So basically, we're going to use a couple of servers as your canaries to make sure that when you go onto your real prod servers, that you aren't going to go ahead and up and stop production. And in this case, for a website, basically bring the site down. So going live. Basically, we go ahead and do some basic tests just to make sure and see the output on an actual prod server as opposed to a test server. And then you can go ahead and actually apply that code as well. Once you've verified that that system actually works, then you can go ahead and merge the pull request and actually push it out to production, such that over some period of time, however you're orchestrating it, either with cron or with the SKU or with mcollective or something like that, or Ansible or anything else you want to go ahead and use for orchestration, you will go ahead and deploy the code out to your prod servers. And y'all do have functional checks for your app, right? Web on external checks are great. If you don't have this kind of stuff, it's really a good idea. If you're not talking about an app in the same way, this is also where your monitoring tools would start checking things and making sure that they aren't firing and breaking. So this is all pretty much after you've pushed it out to prod, but still very important because you're going to detect. The idea is to go ahead and detect a problem if you did mess something up and it did make its way all the way through this entire pipeline. This is where you'd catch it. Much of this code is actually available. I actually have it's on my GitHub. I just made a quick module on the Forge as well. I think it's Matthew Barr -puppet CI or something like that on the Forge. I should have put that up there. Sorry. This code is actually for building out the Jenkins jobs, including and some of the actual scripts that were used from Fog. And it's Red Hat CentOS for now, mostly because I don't have a Debian box to work with, to test, that I needed to go ahead and run Jenkins on. And I'll try to get it updated soon to go ahead and be in current status with the newer Fog code. Another thing we did a couple of months ago at LAPSA East was had a configuration management workflow panel. It came up with a nice list of tools. There were some folks from Puppet, some folks from Opscode, some users of both Puppet and Opscode and Chef. Some folks from CF Engine were there as well, and contributed some information onto a configuration management utilities page. This is just a quick write-up from a Google Doc, so it didn't actually survive Markdown conversion all that well, which is the thing I need to actually fix. But I'm sorry everything seems to be in the state of needs to be updated soon. I'm in the middle of a data center build from scratch, and so we had to prioritize things like making your web servers actually do what they're supposed to do first, before I went ahead and worked on things that were for the external world. This is actually my contact info. If anyone wants to go ahead and ask me any questions, they're welcome to. And anyone later on discovers this and such things, they're welcome to talk about it. Any questions other than the ones we already had? I'm kind of done early. No, silence, crickets. Go for it. We're going to make you get your exercise.
So out of that panel, you discussed tools, but were there any common practices?
So yes.
That are universal across all of the different systems?
What's interesting is I actually pull it up. Let's see if I can do this. Hold on. And it would help if I actually turned my Wi-Fi on. Okay. So this is harder for me because it's not actually on my side of the screen. But we went ahead and there were common practices, things like ID and syntax highlighting were really helpful to a lot of people doing this work, as well as actually tab completion and things on those lines.
Well, that's sort of generic, though. I mean, so
generic, but still very helpful.
Oh, absolutely, absolutely. No, okay. So most of the things you talked about, we were already doing with the PowerShell stuff.
Okay.
With the DSE stuff, all the syntax checking and blah blah blah. I want the extra stuff, right? What else should we be doing? And that's kind of what I'm looking for.
Okay. So some of this is how we do it on Puppet, just because it doesn't have, it's trying to catch it before it's deployed as opposed to after it's deployed.
Oh, yes.
Okay. Yes, some of this stuff would have been caught after you deployed it and ran it on an actual machine. That's great, but you don't really want to catch that then. Some of this needs to be done in ways that are kind of strange because you're trying to do it inside of Jenkins. Because you're not necessarily doing it on a system that's actually the one that's supposed to be asking for that information. You're trying to fool Puppet or whatever tool you're using into giving you information that is not actually about itself, it's about another node. That's not necessarily helpful. In terms of the real stuff that really matters, though, in terms of going beyond, is doing test servers and then doing integration testing on those test servers where you can even have a full stack. We actually run 5 or 8 services on our test servers. That way, in case something is breaking, we'll actually catch it there before it even comes close to the real servers, even the canaries.
How useful has the catalog analysis been?
The catalog analysis helps us catch a type of error for us, and this is a Puppet thing as opposed to, may not necessarily apply to the PowerShell stuff, but it helps us catch problems where files, a class may not have been existent on that node.
Right, yeah, and I think that it would for us as well, because it's the stuff that we generate, the catalog equivalent that we generate, is all fully reified, so you can then go look at the absolute paths and things.
Right.
You can do a lot of checks there that you couldn't do on the source.
Right. So we're actually going ahead, and part of the reason to do a catalog compilation check is so you can go ahead and get the state of the catalog before it actually gets to the system. By doing the check here for a bunch of different nodes, you actually can check before it actually gets to the end user, or before it even gets to the server that would be asking for its catalog, without having to go out and then compile the catalog for every system. In Puppet terms, basically it's a question of whether you're a masterless or have a master. If you're using a master, you don't necessarily need to do these kinds of checks ahead of time. You wouldn't catch the errors before they were deployed. This allows you to catch errors, though, way before that. And then you get into the test servers. And then you can get into rebuilds and things like that, which allow you to test and stress other parts of your infrastructure that you may not actually otherwise test. The test stuff, though, will catch things like you've got version X, which is incompatible with version Y of this other package that's just been updated in your repository. There's nothing you're going to do that's going to catch that inside the code tools, though, because the code says, apply this package. You're handing it off to Yum or whatever installer, and that's where you're going to catch the problem, though. This is the only place, this is the first place that it will catch that kind of a problem. Does that help? So that's kind of where we're going for that. It's just, most of what I'm doing is probably wrong for most people. But at least it starts establishing some idea of where to go from the basics of doing static analysis, which if the tool does it, fine, great, you're getting that already. But it's past that. And how do you go ahead and think about catching problems after you get there and where you go from there? Chris.
So we're doing probably about 75% of what you described, but we're doing the easy and quick 75%.
Okay.
And we parallelize aggressively in Jenkins, and our developers still complain about how long the CI tests take.
Okay.
So how do we add things like all of these vagrant builds and whatnot without bringing the developers to my door with pitchforks and torches?
So the first thing is, we're not using this for our developers. We're using different checks for our developers. We have an actual separate continuous integration server for our developers. So the developers never see this.
Okay.
Basically, this is part of the workflow. What?
Are your developers making changes to Puppet? Or?
Not normally.
Okay. So
your developers are then.
We have about 150 committers to our bconfig repository. So
if you're making a systems change, like to an Apache config or something like that, I'm not so sure I care if it goes out in 2 minutes or 4 minutes. This check set runs about 4 minutes.
Okay.
It's not very long. The other thing is, I'm not actually going ahead and rebuilding the machines every day, every time. Mm-hmm. This is not a clean system build. The clean system builds are not actually happening this often for us, but I think should happen once a night, once a week, whatever it is, but at midnight, when it won't matter. The only person that's going to tell is you that you've managed to fudge up your entire kickstart system, and you probably need to go ahead and do that, fix it, because you can't build systems right now.
Okay.
So the developers won't care. All we're really doing is the catalog compilation. So you're doing the static analysis checks, which are, I'm sorry, the developers are just going to have to deal with actually checking the syntax before I actually. Style guide stuff, okay, fine, pretty safe bet. And honestly, when our developers are using PHP, and they do way more checks and unit tests against their code than we ever do. The other trick is to go ahead and make sure you're only checking the stuff that's in the pull request, not the entire code base. That'll help a lot, especially if you've got a bigger system. In terms of doing the catalog compilation for us, it doesn't take long. It's like 7 servers in there, just one of our web server, a MySQL, a Mongo, a Memcache box, a couple of things that are just things that are likely to break that I really want to make sure aren't going to go ahead and, if we have different data centers, we'll have that in there just to make sure that you're getting systems from both sides so that someone didn't leave off, yeah, they created a new host file for this site, but forgot to do it for that site. Well, that's going to break all the systems in the entire data center if it isn't there. It's really helpful to actually know that you've just broken in a whole data center because you forgot to create a file and it's a template. And then you get into some quick test hosts, which Puppet doesn't take that long to apply on, and they can be parallelized. So if you hold on a second, I will swap back.
Hey, Matt, we're actually running short on time, so I'll take this up with you offline.
Okay. But yeah, there's some things on that, though. You can see anything that's in these paired areas you can actually do. I thought we are just at 47 after. Okay. I'm not as far behind as I thought I was. Sorry. Okay. Great. That's it.